Section 2, excuse me, not 2.6, 6.2. 6.2. Yesterday we talked about what makes an ionic bond and a covalent bond. What we're going to do today is we are going to begin to explore covalent bonds. How do we make covalent bonds? What are some things associated with covalent bonds? How do covalent bonds work? So, before we do that, there's two things we're going to have to do. We're going to review some vocabulary and some background knowledge from the past two chapters so you are in the zone when it comes to talking about covalent bonds. First, we have to talk about what the heck is a molecule. A molecule is a neutral group of atoms that are held together by covalent bonds. We have typically referred to molecules as compounds, which they can be. A compound, however, can be ionic or molecular. If it's an ionic compound, it's an ionic bond. If it's a molecular compound, it is from a covalent bond. Don't ask me why they don't call it covalent bonds. Instead, they use this word molecular, but a molecule is a compound that's formed from covalent bonds, which we just talked about. Molecular compound, a compound made for molecules. All right, so it's a molecule or a compound made from covalent bonds. So instead of really molecules here, we might want to just put in covalent bonds instead. Covalent bonds. Next up, chemical formula. We've talked all about this all year long. What is a chemical formula? It indicates the number of atoms in a compound. So for example, H2O. That means we have 2 hydrogens, 1 oxygen. If we are talking about something more complex like sugars, C6H12O6 would have 6 carbons, 12 hydrogens, and 6 oxygens. We've talked about a wide variety of chemical formulas, just indicating how many atoms are in each. The molecular formula shows the type and numbers of atoms in a molecular compound. So we might have HOH. So it's going to be kind of the skeleton. A molecular compound is going to show us the skeleton. The molecular formula will show us the skeleton, how exactly it is bonded together. So that is what a molecular formula is going to be. All 4 of these terms should be reviewed. We've talked about all 4 of these terms before. We talked about molecular formula when we talked about structural formulas. So molecular formula is really going to show the structure. So these dashes here represent bonds, and it really should look like this. So the dashes represent bonds. Oxygen is bonding with hydrogen twice on both sides. Once on the left and once on the right. The last word that we have to talk about is new to our vocabulary, and it's going to come up quite a bit, and it's diatomic molecules. And these are essentially, these are elements that when they exist have to exist as compounds. So what the heck do I mean by that? Hydrogen gas, when you breathe in hydrogen gas, you're not breathing in hydrogen, you're breathing in H2. When you breathe in oxygen, which is a gas that you breathe in all the time, you're not breathing in oxygen, you're breathing in O2. There are a handful of diatomic molecules on the periodic table. What are they? Well, they are group 17, the halogens. So fluorine, chlorine, bromine, and iodine, they exist as F2, Cl2, Br2, and I2. And then we have hydrogen, oxygen, and nitrogen. Now, you might have to come up with a mnemonic to remember that. I've always went hydrogen, nitrogen, oxygen, halogens, which stands for heck no, that's the halogens. Or you can come up with whatever you want to come up with to remember that. Or you can just say no and have it be NOHH. However you want to remember the diatomic molecules: fluorine, chlorine, bromine, iodine, which are the halogens, and then hydrogen, oxygen, and nitrogen. Sorry, that should be N2, nitrogen. So a little vocab review there. The next thing what I would like you to do is I want us to review how we do the dots. All right? I want us to review how we do the dots. So real quickly, I have, you know what, let's do 3 examples instead of 4. Calcium, lithium, and oxygen. What I want you to do for each of those is do the electron configuration, and more importantly, I want you to do the dot notation. What is the dot notation for each one? So how many dots go around each one? I'll give you a little bit to do that, or a little bit of time. If you need to pause the video, by all means go ahead. But go ahead and do the electron configuration and dot notation for calcium, lithium, and oxygen. Ready, set, go. All right, so with that, here are your answers after a little bit of time. You should have reviewed. Now, if you have difficulties doing this, I'm gonna have to review with you individually. But what we have here is our answers. We have calcium with 2 dots around it, lithium with 1 dot around it, and oxygen with 6 dots around it. Now, one piece of information that's going to be critical when it comes to kind of talking about what we do is, remember, when you're doing your dots, you're going to pretend there's a square around the outside, and you're going to put a dot on each side before you go ahead and put a second dot in. Now, oxygen fits this model perfectly. All right, now, with oxygen, I'm going to refer to, for the vocabulary, I'm going to refer to 2 dots and 1 dot. All right. For all intensive purposes, this is what is called an unshared pair. They're not sharing. We refer to these as married couples. All right. On the flip side, though, these singles here are kind of valence electrons in the outer shell. We're going to refer to these as our single electrons, or what will soon be our shared pair. Now, what we're going to be determined doing is what we're going to start investigating is writing Lewis dot structures. And the purpose of a Lewis dot structure is to show how chemical bonds occur. So you guys are going to be kind of matchmakers. You're going to be dates. You're going to be putting electrons on dates. You're going to leave the married couples alone because they already go on dates, and you're going to hook up the single people as matchmakers on dates. Now, what rule are we going to follow for this? So remember, how many electrons does every atom want in its outer shell? 8. That's called the octet rule. Right. Chemical compounds tend to form so that each atom gains or loses or shares so that they have 8 electrons in their outer shell. Remember, the whole goal is to get 8. And remember, 0 is the same as 8. So if I have 1 and I give it up and I have 0, that is the same as 8. There are a couple exceptions to the rule. If we look at the exceptions, hydrogen and helium only want 2 in their outer shell. There is one exception. And the second exception, which we are not going to talk too much about these elements right away. The second exception comes from sulfur, boron, and phosphorus. But for our initial practice, for the sake of practicing right away, we are going to have 8 electrons in every atom. Now, some review on Lewis dot structures, and then we're going to go ahead and we're going to practice how to do Lewis dot structures. So, Lewis dot structures show molecules with the electron dot notation. So why did we just review electron dot notation? Because it's going to come into play when we're doing our Lewis dot structures. Anytime you have a line drawn between atoms, like we did with H, OH. All right. This line right here symbolizes a single bond. If I had 2 lines, that would be a double bond. If I had 3 lines, that would be a triple bond. 4 lines, quadruple bonds rarely exist, so we really deal with single, double, and triple bonds. Now, unshared or lone pairs of electrons are not involved in bonding. So our unshared pairs of electrons are not involved in bonding. Those are called our married couples. So we already phrased our unshared pair on the last slide. We are not worried about our unshared pairs because those are married couples. We don't put married couples on dates. We're just focused on our singles. So when we do a Lewis dot structure, we're going to show all the bonds of all the outer electrons in the element. So what does this step look like? Well, I want you to, I'm going to make some edits on the fly here real quick. Draw the Lewis dot structure for methane, CH4. So what we're being asked to do is we're being asked to draw what CH4 looks like as a structure and what electrons are being shared with it. So, step 1. When we talk about step 1 from the Lewis dot structure, we are, step 1, determining the number and types of atoms in methane. Well, what elements are in methane? Carbon and hydrogen. How many carbons do we have? 1. How many hydrogens do we have? 4. Easy enough. Next step. We're going to write the electron dot notation for each atom. So the next step in this process is we have to figure out how many electrons go around carbon and how many electrons go around hydrogen. So what we just based on our review, how many electrons do go around carbon? 4. How many go around hydrogen? 1. So when we draw the Lewis dot structure for that, carbon is going to be 1, 2, 3, 4, and hydrogen is going to be 1. So step 1 was to determine how many we have. Step 2 is draw the Lewis dot structure, step 2 was to draw the electron dot notation for each one. Step 3. And step 3 really has to do with guess and check. We're going to determine the total number of valence electrons that we have to deal with in this system. So when we're done, our number matches. Well, we have 1 carbon, and carbon has 4 electrons. 1 times 4 is 4. Hydrogen, we have, how many hydrogens do we have? 4 times 1. So we have 4 electrons. What's the total number of electrons that we have in this system? 8. So when we are done drawing our Lewis dot structure, we have to make sure that we are accountable for 8 electrons. So we identified the atoms, we drew the dot notation. Now, let's play matchmaker and let's put all these atoms on a date and let's make some bonds. Step 4. Step 4. Arrange the atoms to form a skeleton. Carbon is always in the middle. If not carbon, then the least electronegative atom. Well, in our example, what do we have? We have carbon, so I'm going to put carbon in the middle. Then what am I going to do? I'm going to put the rest of my atoms around the outside, but I'm going to put them equally apart from one another. So I'm going to go H, 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 H. If I had 3 atoms, I would put maybe just here. Or if I had 3 could look like this. All right. Or it could look like this. All right. Or it could look like this. It doesn't matter how you rearrange them around the atom as long as you have as many. So we have CH4. That's what we have to do. So we arranged our skeleton. Now what do we have to do? Well, we have to put in our electrons. So first it says add our unshared pairs of electrons. Remember, our unshared pairs are our married couples. In this example, does carbon have any married couples? No. Does hydrogen have any married couples? No. So we're going to move to the next step. The next step is we're going to add our single electrons. So how many single electrons did carbon have? 1, 2, 3, 4. And how many did each hydrogen have? 1. Now I'm going to put this 1 facing its date. Why am I going to do that? Because soon we're going to pair them up and make a date. So once we've added our single electrons, we're going to make bonds. All right, time to go on dates, guys. I'm going to just make an easy date there, an easy date here, 1 there, and 1 there. My last step is twofold. All right, I'm kind of going to get rid of the dots and I'm going to clean this up. So when I clean it up, my final answer is going to look like this. Shoot, mistake. My final answer is going to look like this. Each line represents a date. It takes 2 people to go on a date. So then we double check and we do our double check. We're going to double check the number of electrons. Each bond is 2, 2, 4, 6, 8. We have 8 electrons. How many electrons did we have when we started the process back here? We had 8, 8, and 8. That, my friends, is a good Lewis dot structure. Now, I'm going to walk you through 2 more examples. If you feel super confident in your ability, all right, you can fast forward and see if you got the answer correct on both of these as I do them. If not, not a big deal. So, we have CaCl2. Well, first, let's identify what atoms we have. We have Ca, and we have Cl. Next up is the Lewis dot structure. Well, what is the Lewis dot structure for calcium? How many dots should go around calcium? 2. How many dots should go around chlorine? 7. All right. Now the question is, all right, before we go to the next step, how many married couples does calcium have? 0. How many married couples does chlorine have? 3. How many single people does calcium have? 2. How many single people does chlorine have? 1. The next step in the process then is count the total number of electrons. Well, we have calcium. We have 1 calcium times 2 electrons. Chlorine, we have 2 electrons times 7. We have 14 here and 2 here. We have to end up with 16 electrons. All right, next up then is we have to make our skeleton. And remember, we put carbon in the middle. If we don't have carbon, we're going to put the least electronegative element. Well, looking on your electronegativity chart or knowing your electronegativity trend, which one of these has a smaller electronegativity? The answer, calcium. So I'm going to put calcium in the middle, and I'm going to surround it by chlorine. I'm going to just put a chlorine on each side. Now, I could have put chlorine on top and bottom. I could have put chlorine on top and left. I went left and right. You could have went bottom and right. It doesn't matter as long as you have 2 chlorines around it. Next up, we're going to put in our married couples. Does calcium have any married couples? No. Does chlorine? Yes. How many married couples does chlorine have? 3. I'm going to put those in as far away from calcium as possible because remember our married people don't go on dates. All right. Next up, I'm going to put in our single people. Now, how many single people does calcium have? 2. Now, it might help you guys if you represent the single people using X's and the married people representing circles. So when you go on dates, you can only hook up people that have X's. All right, so calcium, we're going to go X, X. How many single people does chlorine have? 1, X, X. Next, we're going to play matchmaker. Just like that. We're going to double check that we got all our electrons. When we double check, we have starting here 2, 4, 6, 8, 10, 12, 14, 16. We have 16. We're good to go. Last thing is we're going to get rid of all our married couples and just show our dates. There is our Lewis dot structure for CaCl2. Next example, AlBr3. Same type of thing with AlBr3. We're going to go Al and Br. What's the Lewis dot structure for aluminum? How many dots does it have around it? 1, 2, 3. How many does bromine have around it? Bromine has 7. How many single people does aluminum have? 3. How many married couples or unshared pairs does bromine have? 3. Right. Now we're going to double check aluminum. I have 1 times 3 electrons. It's 3 electrons. For bromine, I have 3 electrons times 7 electrons. It's 21. I have to match 24 electrons. Next up, I'm going to create my skeleton. The least electronegative atom goes in the middle. If it's not carbon, carbon always goes in the middle, but other than that, the least electronegative. So aluminum's the least electronegative. So I'm going to go Al, Br, Br, Br. Now those BRs could be anywhere around Al. It doesn't matter. There's not really a preference. I just chose that. Next up, we're going to put in our married couples. Does aluminum have any married couples? Or unshared electrons? No. How about bromine? Bromine has 3 sets of unpaired or lone electrons, what we've been calling our married couples. All right. Next, we're going to put in our singles, or our unpaired, or excuse me, our ones that we're going to pair, our paired electrons. So our singles, how many singles does aluminum have? 3. 1, 2, 3. How many open electrons or single electrons does bromine have? 1, 1, 1, 1. Let's go ahead and make bonds. Let's double check that we have all our electrons accounted for. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Our final answer then would be to make this into good notation by getting rid of our married couples. Just like that. And that is a good Lewis dot structure. Right. For the remainder of the hour, what I would like you to do is kind of practice those Lewis dot structures on the worksheet that you're going to be getting. So practice that. If you have questions, we will talk about that in class tomorrow.